Okay, today's lesson will be on 6.5, solving radical equations. So when we go to solve radical equations, one of the first things that we need to do is we need to isolate the radical, or if we have a rational exponent, remember we know ways to change a rational exponent into a radical form, so both of those would be representing the same thing. So before we do any undoing inverse operations or getting your variable by itself, we need to isolate a radical or rational exponent. Okay, we may also need to check for extraneous solutions. Okay, so those are answers that we derive but do not satisfy the original equation. When we substitute it back in, we get a false answer. Okay, this is going to happen when you get two solutions, which is only going to happen if your equation turns quadratic. So we're going to come back to solving quadratic equations with a few of your problems today. Okay, we won't get to that till our last example here, but with our first three, first we isolate any radical that we have. With number one, we're just starting simple. The radical square root of x is already isolated, so then I need to undo the radical. If I have the square root, I must square to undo it, and then I have to balance my equation and square the other side. So then x would equal 100. Okay, hopefully that makes sense because the square root of 100 is 10. Okay, with number two, one more step to do than what we did in number one. I cannot square it first. I must isolate my radical, so I will subtract 4. So then I get the square root of x equals 144, and then I can square both sides. So when I square this, that will undo my radical, and then I'm going to square 144. So x is going to equal 20,736. Okay, you can go back and plug that in, take the square root of 20,736. It'll tell you it's 144. You'll add 4 and you get 48. Okay. Our next problem here. Once again, I will isolate the radical. So I have this plus 2 on the outside, so I will need to subtract it first. Now that 3x minus 2 is inside of that square root, so I have isolated the radical. I can now square both sides, and when I square it, I'm undoing that square root. Make sure you square the other side as well. And since I'm undoing that square root, I don't actually have to square that 3x minus 2, okay? If you did, you would have squared it twice, which is unnecessary and a lot of work. So 3x minus 2 would equal 16, and then you're solving for x. So add 2, 3x equals 18, divide by 3, x would be 6. Okay, when you go back to plug that into the original, you'll take your 3 times 6, 18, minus 2 is 16, take the square root and get 4, 4 plus 2 would give you 6. Okay, our next two equations here. Now both of these examples for number 4 and 5 have rational exponents. Okay, so remember we can change that to a radical form. So that means that we still need to isolate the rational exponent, or what is being raised to the rational exponent, since that's technically a way we could write a radical. Okay, so my first step here, I'll undo addition and subtraction that I have. Okay, I cannot distribute that 2 times the 5x and the other 2, because that is being raised to the 1/5 power, and the 2 that's on the outside is not. So I'm not going to distribute. I'm going to divide by 2 to undo it and continue to isolate what is being raised to that rational exponent. So now I've got 5x plus 2 to the 1/5 power equals 2. at any time in this problem, we could have done it from the very beginning. If you'd rather write this as the fifth root of 5x plus 2 equals 2, you know, you could have done that from the very beginning if that's helpful. Maybe you wouldn't have, I know I have some students who will try to distribute it right up here, and maybe you wouldn't have done that if you would have switched it from the beginning to that fifth root. So if that's helpful, go for it. But to undo a fifth root, we would have to raise it to the fifth power on both sides. So that's going to undo each other. I'll put it over here. So now I have 5x plus 2 would equal 32, because I had to take 2 to the fifth power. And now I can finally get x alone. Subtract 2, divide by 5. So x would be 6. Okay. Something else, if you did not want, so at this point right here, if you did not want to change it to the radical form, if you raise it to its reciprocal power, so 5 over 1, which is what we did in the radical form, then I don't have to change it to the radical form and raise it to the fifth power. Okay, so that's up to you. You can leave it in the rational exponent form the whole time, or you can change it to the radical form. Whatever makes more sense to you, you're doing the same steps either way, it just has a radical instead. Okay? All right, for number 5, okay, similar problem here. So once again, that 3 is on the outside. I cannot distribute it because that x plus 3 is being raised to an exponent, so I can't multiply before I take an exponent. So my first step will be to divide by 3. So I have x plus 3 to the 3 over 2 power would equal 27. Okay, similar to the last problem, now you're welcome to do one of two things. You can convert this to x plus 3. 2 on the bottom would be a square root. This is the third power equals 27. If that's helpful and you want to undo things that way, go for it. You're also welcome to leave it in this form and do what I was talking about, where you can raise it to that reciprocal power. So if I have 3 over 2, I can raise it to the 2/3 power on both sides. Because when I raise a power to a power, I'm multiplying those exponents. So when I'm taking 3/2 times 2/3, I will get 1. So it is undoing the square root and raising it to the third power at the same time. So it's more efficient, I guess. So then this turns into just your x plus 3, because you just undid that rational exponent, and then I will need to find the value of 27 to the 2/3 power. Okay, which if we just convert that back to the cube root of 27 squared, cube root of 27 would be 3. 3 squared is 9. So what value of x plus 3 would be 9? Would be 6. Okay, that's typically what I do, is I raise it to that reciprocal power. To me, it's less steps than what I'm going to do if I chose to go this route, but it's up to you. Okay, so right now I have a square root here, so I need to undo the square root and raise it to the second power. So I'll raise this to the second power, and I'm left with x plus 3 to the third power equals 729. Okay, then I have a cube root, so if I'm going to undo the cube root, I must do that on both sides. So then a cube root and cubing would undo each other, so you're left with x plus 3 equals, the cube root of 729 is 9, so then I get the same result of x equals 6. Okay, up to you. What makes more sense? If you convert it to that radical form, you're just going to undo the radical part and then the exponent part, okay, versus doing it all in one step here. Your choice, doesn't matter to me, okay? All right, our last example here. So once again, isolate your radical, get it by itself. I'm going to add 3. 3 is not under that square root. And I can't actually add 3 to the x, so I'm just going to write x plus 3. Okay. All right, I've isolated the radical. I am ready to square both sides. So I'm going to undo that radical. When I square the right side, I'm not just going to write the squared at the end, because that means I'm only squaring the 3. I'm squaring this entire side, so I'm going to need to use parentheses. So 17 minus x equals x plus 3 squared. When I square that, make sure you write it out twice and actually distribute this, because if it's separated by addition and subtraction, you need to use FOIL or double distributing. Okay, I can't just square the x and square the 3 when I'm adding those two together. Okay, so I will get x squared plus 3x plus 3x and plus 9 would equal my 17 minus x. So I've got an x squared here. So right now I'm going to be solving a quadratic equation that we did last quarter. Okay, I promised you this would come back in every chapter. Here it is in our last section here when we're solving these equations. So I'm going to need, I can go ahead and combine that to 6x right now if I want. But to solve a quadratic equation, you'll need to get it equal to 0 to either factor or do the quadratic formula. Okay, so I'm going to go ahead and add x over, and I'll subtract my 17 over, so I can get 0 on one side. So I've got an x squared plus 7x, and 9 minus 17 give me negative 8. Okay, from here, you can make the decision. You've learned the methods that we have. I can't do square roots with this one because I have an x squared and a 7x, so I can't get my x squared by itself, so my options are factoring if it's factorable and the quadratic formula. Okay, I believe, if I remember correctly, all your problems are factorable in your homework and on your quiz and on your test, so you wouldn't have to use the quadratic formula, okay, but you certainly can. This one is factorable because there is a number that multiplies to negative 8 but adds to 7. Remember, my a value would be 1 in front of that x squared, so I don't need to worry about kind of the guessing and checking piece. It's for sure going to have a positive and a negative number to multiply to negative 8, and I will have a positive 8 and a negative 1 would multiply to negative 8 but add to 7. And then you go ahead and set each factor equal to 0 to find your solutions. So this would have to equal negative 8, and this would have to equal 1. So those are the two solutions that I get. But remember, quadratic is going to give you two solutions for this graph, but maybe it doesn't make sense for the actual original problem. So this is where you can have extraneous solutions. Sometimes both will work. Sometimes only one will work. It's possible neither could work. We're not going to see much of that. Okay, so I will have to test both of those answers in the original problem. Now, if I did everything correctly, those two answers should work in the equation I have up here, because that's what I solved as a quadratic equation, but it might not work in the one that has a square root because we've got some issues with square roots. So I'm going to go back and check those answers. So I'll start here with x equals negative 8, and I'm going to plug that back in. So 17 minus a negative 8 minus 3 would have to equal negative 8. So if that's true, that is one of my solutions. This will turn into plus. So I have the square root of 25 minus 3 is 5 minus 3. That does not equal a negative 8. So this answer would not be one that I would include. Okay, it is an answer that satisfies this equation, but not the original problem I'm solving. So I'll go ahead and check one. One should work, but we'll make sure that it does. So I've got the square root of 17 minus 1 minus 3 would have to equal 1 for it to be true. So this is the square root of 16 minus 3. So 4 minus 3 does equal 1. So this would be the only answer I would include. You don't have to erase your work or anything, but when you're entering it in Math Excel, you'd only put in 1. Okay, if you had both answers, it's going to ask you to put a comma in between them. Okay. If you wanted to do the quadratic formula on this, just a reminder, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. You are welcome to use that. I'm not going to give that formula to you on your test, so you will have to be familiar with that again if you're going to use it. Like I said, your test today will be factorable, so you can just go back to factoring. Okay, and if you're like, well, I don't know if I really remember factoring, the next chapter we're hopping into, you will need to factor in every single section. So my suggestion is to just practice factoring right now to help you get ready for that chapter again. Okay, that is it for our lesson today. Good luck on your homework. Let me know if you have any questions.